When I get home, I want you. When I get home, I want you. Hello, 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 I got places to be.
Have you ever wondered how platforms like LeetCode, CodeChef, or CodeForces work under the hood and how you can make them? In this video, we are going to discuss the code and architecture of these platforms so that you can build them too. So without wasting any time, let's directly get into the video. So first, let's talk about the design of this project. I have divided this project into three parts: front end, primary, backend, and the worker. Let's see how they communicate with each other. Whenever a user submits the code, front end sends a request to primary backend, and the normal HTTP request is upgraded to an WebSocket connection. Now, if you are confused, let me tell you what's a WebSocket connection. Whenever you send a normal HTTP request to a backend, a response is returned and then the connection is closed. But in a WebSocket connection, a normal HTTP connection is upgraded to persistent connection. A handshake between front end and backend happens and then a persistent connection is established. In normal HTTP connection, backend can send response only when the front end sends the request. But in WebSocket connection, after the persistent connection is established, backend can send response to the front end whenever the backend wants. Why we have used WebSocket connection? Because I don't want front end to send requests again and again to primary backend and check if the code has been evaluated or not. Now let's move on to the next part. Whenever a user submits the code, the primary backend pushes the code to a Redis queue and the worker pops from the Redis queue and start evaluating the code. Now, why we have used queue, why there's a separate worker, why can't we evaluate the code on primary backend? So first, let's talk about why I have used a separate worker. I've used a separate worker because evaluating the code, comparing it against 50, 200, or maybe even 1,000 test cases is an expensive process and can take many seconds in worse situations. So we don't want primary backend to be blocked in that case, because imagine if 100 people are submitting code on your website at the same time. You don't want primary backend to be blocked. That's why we have used a separate worker here. So whenever a user submits the code, the primary backend pushes the code to a queue, and pushing it to a queue is a really not so expensive process. It takes very few milliseconds. So the primary backend is not blocked even if many users come at the same time and submit the request at the same time. And then the worker pops it from the queue and sends it to the primary backend, and then the primary backend sends it to the front end, and then the WebSocket connection is closed. Now, why we have used a queue here? Why can't we directly send code to the worker and then evaluate the response? If, for example, 100 users submits the code at the same time, we don't want worker to evaluate that code of 100 users at the same time, because Nodejs is single threaded, and then the context switch between one code to another code will keep happening and none of them will be evaluated properly. It will take a lot of time to send the response of one user. User will have to wait a lot. So that's why we have used a queue here, so that the worker only executes one user's code at a time and then move on to the next one. So that the context switching between one user's code and another user's code does not keep happening. So it makes the process much more efficient compared to if worker is evaluating 100 users code at the same time, which doesn't make sense. Now, how does the worker sends back response to the primary backend? I'm using PubSubs for that. Now, what's PubSubs? PubSub is basically publisher subscriber model. For example, you can consider this WS when as the primary backend. WS means the topic. For example, the primary backend has subscribed to the topic submissions. Now consider this as the worker where the PubSub is written. Now, after evaluation of the code, the worker publishes the response of that code to this topic. If there are multiple backends, multiple WebSocket connections, whoever are subscribed to this topic will get the response and they will be able to send it back to the user. But there was no need of PubSub here, I think. I should have used a normal queue. It's an over-engineered solution here because I am not gonna use multiple WebSockets connection. Let me give you a use case of PubSub. PubSub can be used in applications like a chat application. For example, a user lives in India and is connected to this WebSocket connection. Then another user lives in USA and is connected to WebSocket 2 connection. So if this user wants to send back message to user 2, then this WebSocket connection and this WebSocket connection can subscribe to a same topic, for example, message. And this PubSub connection can send request to that topic, and then this user one will be able to communicate with the user 2. In these cases where you have to make multiple WebSocket connection, different WebSocket connection for different regions, and where one user wants to interact with the user where who's on another WebSocket connection. In this case, you can use PubSub, but I don't think this project required using PubSub. I could have used a normal queue for that. I think it's an over-engineered solution. Do tell in the comments what do you think about it. So after receiving response from the worker, the primary backend sends back the response to frontend, and then the WebSocket connection finally closes and the response is shown to the user. Now there's one more thing here. I've containerized the whole worker. What does containerization mean? Containerization basically means I have isolated the whole worker from the main server where it is running or from any computer where it is running. Now I have containerized this application. I have containerized this application because I am executing user's code on a shell, and user can type some commands like ls or rm, which can rm can remove any particular file on a system, which can interrupt the server running if the worker was directly running on the server, because some file will be removed, maybe some dependency have been deleted by the user. That's why I have containerized this worker so that this worker runs in an isolated environment separate from the server, so that even if user runs some command like rm, which is for removing file, it cannot affect the main server. So even if the worker dies, I can bring that worker up again through Kubernetes. I will discuss that later. Running that type of commands won't affect the server, and server will keep running properly. So now let's move on to the next part, which is Kubernetes. Why I have used Kubernetes? Kubernetes basically help to manage the Docker containers. With the help of Kubernetes, I can create multiple instances of worker whenever the traffic increases. I can do many things like whenever a worker dies, I can bring that worker up using Kubernetes. So this was a very high level of Kubernetes. I'm not going in depth with Kubernetes in this video. If you want a video on it, do comment down below. Now let's move on to the code part of this video. Now let's understand the flow of execution. Whenever a user submits the code on frontend, it establishes a WebSocket connection with the primary backend, as you can see here, and then it it sends the request to this API endpoint submit code. Now, what does this do? This basically pushes the problem to the Redis queue. As you can see here, this pushes the problem to the Redis queue along with question ID, code, language, test cases, configurations, difficulty. As you can see, this code is received here in the worker. The worker starts running all the test cases, executes it in the shell using these commands. And if the answer doesn't match, it returns the wrong answer response, or it, as you can see here, or if it includes an error, it sends the request. It sets the status as runtime error and send it to the primary backend. As you can see here, it is publishing to the submissions topic here. As you can see here, primary backend has subscribed to this topic submissions. So whenever the worker sends publishes the response to this topic. The primary backend receives the response and then puts the response in the database and then send it back to the user. And after this, the WebSockets connection is closed on the front end. So this was the whole flow of the code. So that's it for this video. If you really enjoyed this video and found it helpful, don't forget to like, subscribe and share it with your friends. Do comment down which type of videos do you want in the future. And if you are someone who is just starting out with web development, you can watch a video of mine which is appearing here. I'll see you guys in the next one.